A very good morning, students. Welcome to Gardenia Public School online class. Myself, Vabo sir, and I am your science teacher. And class, this is your science period. Clear? Very good. Okay, now class. So, before starting this video, this is first instruction for you. This is only a board explanation. No need to note in your notebook. Is it clear to all of you? Very good. Okay, now class, today we are going to start a new topic, and new topic is about lens. Okay, so don't wasting our time, let's see. Okay,
Let's see who's at the door.
You looked so scary through the peephole, James.
Images seen through a peephole are different from those seen through a normal glass. This is because peepholes contain concave lenses. And what are concave lenses? Well, let's find out. In this lesson, you will learn about images formed by lenses. At the end of this lesson, you will be able to identify the different types of lenses, distinguish between the characteristics of images formed by convex and concave lenses, and list the applications of convex and concave lenses.
What kind of lens is that?
It's a concave lens. But I'll explain about that later. Right now, I need to go get my watch repaired.
Can I come with you to the watch repairer, please?
Oh, all right. Only if you promise to stay close and not touch anything without my permission.
I promise. How does he manage to locate and fix such tiny parts?
See the eyepiece? It has a lens that magnifies the images of the parts of a watch. Take a look at this magnifying glass.
Oh, but the lens in our peephole made you appear smaller.
That was a concave lens. The watch repairer uses a convex lens. A convex lens makes objects placed close to it appear magnified when seen through it. See?
Yeah, you're right. I can see the parts so clearly.
This is the lens used in the eyepiece that the watch repairer uses.
It is thick in the middle and thin at the edges.
Yes, convex lenses are thicker in the middle. Concave lenses, the type used in peepholes, are thin in the middle and thick at the edges.
Hey, that cup looks inverted through this lens.
Yes, that can happen when you view an object through a convex lens at a specific distance. This magnifying glass you have just seen is also a convex lens. I will show you what happens when we view objects through it after we go home. Never try this on your own, okay? You may burn your hand if you're not careful.
It's dangerous to look through a lens at the sun or a source of bright light. You should also be careful not to focus sunlight with a convex lens on any part of your body.
Oh, how did the carbon paper catch fire?
When light rays from the sun pass through a convex lens, the rays bend inward while passing through the lens. These rays converge at a common point to form an image of the sun. That's the bright spot you see on the carbon paper. As sunlight carries heat, the heat generated at this spot increases, and finally, the carbon paper catches fire.
What if I used a concave lens? Would I be able to focus sun rays with a concave lens?
Well, no. Images form differently in the two types of lenses. Convex lenses converge light rays. It is because of this converging property that a convex lens is also called a converging lens. However, in a concave lens, light diverges or bends outward. Therefore, the rays of the sun that are incident on a concave lens get diverged or deflected away from each other after passing through the lens. They do not focus on a single point, unlike in a convex lens. This phenomenon is called divergence. Hence, a concave lens is also called a diverging lens. Come, I will show you how it works. I have placed the illuminated toy close to one side of the convex lens. I am focusing the lens on the white wall. Now, tell me what you see on the wall.
I can't really make out.
That is because when you place the lens close to an object, you get a virtual image of the object. The image is direct and magnified. But virtual images cannot be formed on a screen. In this case, the wall. So, you're not able to see anything on the wall. That is why the watch repairer in the shop was holding the eyepiece so close to his eyes when looking at its parts.
Oh, yes.
Okay. Now, what do you see?
Yes. Now I can see an inverted image of the toy on the wall. How were you able to get an image on the wall this time?
This time, I increased the distance between the toy and the lens by moving the toy away from the lens. I also adjusted the position of the lens and the toy so that you could catch a clear inverted image of the toy on our screen, the wall. Images that can be caught on a screen are called real images. As I mentioned earlier, virtual images cannot be caught on a screen. Therefore, this image is a real image. When light rays from the lamp are incident on the toy, the reflected light from the toy passes through the convex lens that is kept at a distance. These rays form an image of the toy. The first time, you could not see any image on the wall as the lens was very close to the toy, and the image formed was virtual. Virtual images do not form on the wall. However, with sufficient distance between the object and the lens, a real inverted image is formed, as you just saw. Now, let's try looking at images with a concave lens. Tell me what you see.
Nothing on the wall.
Yes, you cannot observe it on the wall, as it is a virtual image. Here, you can see the image through the lens.
I got it. The image is small though.
Yes, the two lenses form different types of images. When the light rays incident on the toy pass through the concave lens, the rays form an erect, virtual, but a smaller image of the toy. Now, talking about images formed by a concave lens, where have you seen another image formed in a concave lens recently?
Your image through the peephole.
Exactly. Even though my face looked odd, you could make out that I looked smaller.
James, can I take these lenses and experiment with them for a bit?
Sure, but handle them carefully.
Hey, I know what lenses these are. These are convex lenses. You need them because you can't see the small letters on the page clearly. Right, Dad?
Uh-huh. That's correct. And do you know the other applications of lenses, Tim?
Magnifying glass, peephole?
Camera, bioscope, binoculars, telescope, microscope, projectors.
So do all of these have convex lenses?
Not just convex, some have concave lenses, and there are others that have a combination of both concave and convex lenses.
Really? What exactly do we use concave lenses in these things for?
You want to know more? Let's see what the internet says. There, concave lenses are mostly used to make details of objects look clearer, like binoculars and telescopes.
Oh, of course. Scientists need to study small objects in detail in the laboratory. So concave lenses would help.
This brings us to the end of this lesson on images formed by lenses. In this lesson, you learned to identify the different types of lenses, distinguish between the characteristics of images formed by convex and concave lenses, and list the applications of convex and concave lenses. We hope you enjoyed the lesson. There's much more to come.